enable host-to-host communication. End-to-end communication. In fact, it is application-to-application communication. So this is the transport layer. So how does the transport layer implement it? With a parameter called port. Then please pay attention. This port number is a logical port. That is, it is not a tangible. It is a logical port simulated by technical means. For us, the port is based on the host. An application-level concept. Different ports correspond to different host applications. Then here, we're going to make a modification to it in the diagram. That is, based on the network layer. The transport layer can implement a virtualized port. Use these different ports to locate different applications on the host. For example, now this host has downloaded 3 applications. Connected a WhatsApp, a WeChat, a YouTube. Make an identification. Suppose this is WeChat. This is YouTube. This is WhatsApp. Logically speaking, we don't know. What is the relationship between them? That is, there is no port number to differentiate. For example, WeChat port is 100 locally. YouTube port is 200 locally. Of course, when I tell you about real communication, these ports are not available. These cannot be used casually. Then the port 100. Right on the PC. Identify the WeChat app now. Then 200 identifies YouTube. Future. When the device is in data communication, it will carry these parameters. Please pay attention. This is the reply packet. This is the message sent. In it, we'll add something. For WeChat, when the device accesses 192.168.1.2 locally, it will carry the local port number of 100. It will be preceded by a logo. Is a colon. Represents this data communication. Initiated by local WeChat. Certainly. The peer does not care what your local port number is. So what is the use of this port number? The data sent by the device. How many ports? For WeChat server. It doesn't matter. If many devices access the WeChat server in the future. How to distinguish? Based on the TCP protocol. You will learn in subsequent advanced courses. TCP will communicate with some other clients. This is called the server. The server is called the client. If the connection is based on TCP, there will be a unique identifier for the session. That is, establish a TCP connection. On the server side it is unmistakable. That is, WeChat is now establishing a TCP connection with the device. Then this port number is actually, it's not there to help it with data differentiation. But when the data replies to the data packet, reach this device, it knows that it corresponds to the program on the device. This is for the initiator. A more meaningful port. Of course. Data communication. Address-to-address exchange. Then if it comes with the port number, it also needs to find the port number of the other party. So now for the other party. Assuming their port numbers can all be the same. For example, they are all port 1000. Now for data communication. In fact, it is accessing its 1000 port. The same is true below. I wrote the same mainly for the convenience of copying. It doesn't matter if they are the same or not. If now go to visit 3.100. It is a local YouTube to initiate. That is 200. Let's visit here. Further down is 300. For us now. During data communication. When data is sent. That's how it's sent. Local 1.1's 100 to find 1.2's 1000. 1.1's 200 to 1.3's 1000. The data came like this. Then when the data is sent now, it is necessary to respond to the corresponding data packet. Then when the data packet is replied, it will be different from before. It's not just address to address. Instead, add the port from the address. Reply together. That is, when the reply packet is sent again, we will put the overall source IP and destination IP, plus source port and destination port. Swap all. Let's see now. Now WeChat, YouTube, and WhatsApp all reply to PC. Then when the device receives this data, can it differentiate between different applications? Not just now. Because there is only one address. It does not distinguish between applications. But now it's okay. It received a data. If you are accessing port 100 of the current device, it knows that it is WeChat data. The data that was indeed sent to WeChat just now. What is sent is the port carrying 100. So, if there is a data reply in the future, the access is the local port 200. It knows that this is YouTube data. And then sent to the upper level. Apps like YouTube for processing. So this is the overall logic of data communication. That is, when we exchange data, instead of just taking one IP address and sending it over, instead use the port corresponding to the application plus the IP address. This combination, data communication together. For the peer device, communication and visits are equal. This is data communication. What I told you here. We will intervene in 4 layers in the future. Actually, more is to pass the application data of the upper layer. Speaking of this, you may be a little curious. During class, let's just look at the ARP message. It seems that there is no TCP in it. We have a lot of agreements. It works at different levels. What we learned about the transport layer. It is more for the application of the upper layer to serve. That is, future. You will be exposed to all kinds of real business data. Then in each business data, it is all identified by the transport layer. But the ARP we learned, you can think of it as a small function. ARP is a layer 2 protocol. Let me tell you about our verbal addressing habits. This is ARP. This is E2. Followed by the frame end of E2. The front is its frame header. The upper layer of ARP has no content. Actually, the question you want is, the device now wants to send a data to the peer. It is 1.1. It is 1.2. Assuming they are directly connected. Same network segment. The device is now going to send data to it. Because the device does not know the MAC address of the peer. The destination MAC of its data link layer cannot be encapsulated. I send an ARP now. Go ask what is the MAC corresponding to this 1.2. Before the device sends this ARP packet. Actually, data encapsulation cannot be completed. That is, before the device finds the peer MAC. It has no way to pass the application data it really wants to pass. So we can only use a small function first. It's ARP. It's more like a functional protocol. Then, for such an agreement, it has a very clear purpose. This message is sent just to request MAC. Then after replying, when sending data, this is the complete data package. Second floor. 3 floors. Source IP and destination IP. The 4-layer assumption is TCP. This is WeChat server.